Dear student, in this video I'm going to talk about how to find the probability if you have a discrete random variable without specifying the distribution of the dataset. Let's see the first example we have. The mark of 60 students are recorded in a dataset with a file named student.rds. You will find this file in the MS Teams. You can answer the following question using this file. Since we don't know the distribution of the following dataset, we cannot use any function of binomial, Poisson, or normal distribution. So if we want to find the probability for this dataset, we can use the command mean, and then the file name is written in the environment is a student. Then we press on $, we get the variable we have, mark, and then we want here in the first question find the probability of less than 60. So we'll write less than 60. So this command will count how many data in your student's file has with a value of less than 60. So it will calculate the frequency and it will divide it by the total number of students in your data set. So the answer is, you will get it in the console window. The answer is 0.633. You can round your answer into 2 decimal places by using the command round. Now let's move to the next question. What is the probability that the students score above 80? Again, we are going to use the same command mean student as a file name $mark. Above 80 means greater than 80. Run your code. The answer appear in the console window. You can copy paste your answers in the running window. Okay, this is regarding in general if you have a data frame and you want to find the probability. Now let's assume that we are dealing, we need to run a random variable or generate random variables using some distribution. So first of all, let's use a binomial distribution. We want to generate 20 random numbers using binomial. We know that in binomial, the parameters are n and p. N is a number of trial and p is a probability of success. Whenever you generate random numbers, you have to specify the seed you start with. So the first command we write is set.seed. This is very important command, and don't run this command alone. You have to run it together with the command rbinom. So whenever you generate binomial random number, the command start with the letter R, then with the first 5 letters of the word binomial. Inside rbinom, we have to enter 3 things. N is how many data you want to generate. Don't confuse between the n you have in binomial and n, the number of random numbers you need. N, you need 20 random numbers. Size is the number of trial we have, which is n in binomial, 35, and prob is the probability of success, which is 0.25. Once you click run, you have to highlight first of all the first 2 commands and run. Normally we ask to save these output in the environment, so do not run it like that. Try to save your random numbers in the environment with any name and run it again. So we have x is a generated numbers using binomial, and X has 20 numbers. In the first question, I ask display the first 15 numbers. Means inside X, you just extract the first 15 numbers. So 1 up to 15 means X will be displayed and only the first 15 number will be displayed in the console window. Normally we ask just for one value from this generated number. Let's ask you that find the fifth value of the generated random number. So I want you to extract from X the symbol you use to extract any value from your data set is this bracket, and then you write the position of the value, the fifth value I want to display. The fifth value in your generated data set is number 9. Hope that is clear to you. Once this is clear to you, you can use the same idea and generate random numbers using another discrete distribution, which is Poisson distribution. Poisson is known with the parameter lambda. So in order to generate Poisson, for example, 35 random number using Poisson distribution, first of all, you have to set the seed given to you in the problem, 446, and then the second command is rPoisson, and then how many Poisson number you want to generate, and then specify the lambda value you have in this problem. Lambda is equal to 2.5. Run both codes together in order to get those numbers fixed. Now we have generated 35 numbers. I want to display the first 15 numbers. So first of all, let's save this, our output of the generated number with a name, with any name, and run it again, those two lines of codes. Now you can display the first 15 numbers using the bracket we use for extraction from 1 to 15. These are the first 15 numbers in the binomial random numbers. I want you to know what is the fifth value. You can count or you can use the command y, extract the fifth number from the y. So you get it like it's equal to 1. Now let's see, whenever you have to generate normal distribution, remember that normal is defined by two parameters, which is mean and standard deviation. So again, we are going to set the seed, set dot seed. The seed is set into 23. The command we use start with the letter R, norm. How many number you want to generate is 15 numbers, and then write your value of the mean. Just see how it's displayed in the yellow. Go with the same order. By default, if you put 0, it is the standard normal random, but we want in general random normal numbers. So mean is given here in the problem is 5, and the standard deviation is given here as 5 also. Take the two codes and run it together. We are getting, why this time we are getting decimal numbers? Because normal distribution is a continuous distribution. Again, save this with any name. Let's save it with a name B, for example. Run it together again. Keep it safe in the environment. Now, I want you to display the second value in your random numbers. So B, extract the second element, and you get the second element is shown as 2.82. You can round your answer into 2 decimal places. This is regarding how to generate random numbers. Now let's move. How do we find probability for a binomial random number or binomial random variable? If x is binomial with number of trial as 40 and probability of success as 0.35, then find the probability that x is equal to 4 or x is exactly 4. To find the probability whenever you have to deal with equal sign only, then you can use the command D. D is only used if you have an equal sign exactly 4. You want just to find one value of the probability. So D binom, write your value for x. Then see here in the yellow, they are just giving you the hint how do you write. So x first, then n size is the value of n 40, and prob is the probability of success, which is 0.35. Run this code. The answer is 0.002523781. You can round your answer into 3 decimal or 4 decimal as you want. This is used when you have to deal with exactly one value. But when we say find the probability of x is less than or equal to 4, or x is at most 4, at most 4 means you're not only taking 4, you want the probability of x equal to 4, probability of x equal to 3, 2, 1, and 0. In order to calculate the sum of these probability from 4 up to 0, you can use another command, is p binom. So p binom is used when you deal with less than and equal only. So we start with the number we have 4. So x equal to 4. Size is equal to 35. The n is 40. And probability of success is 0.35. Okay, let's see what we have here. Just, I think we write 4. It's not only 4, it's 4 and less. So just write like that. Yes, it's correct now. Okay, next. What we mean by x less than 4? Do we have any command in R where we can use a probability of less than 4? No. Less than 4 is same as probability of x is less than or equal to 3. So when we use this command p binom, we start with number 3. P binom 3, comma, size is equal to 40, probability of success is 0.35. Some of you, they write directly without writing this size and prob. You can do that also. Okay, so this is the final answer. Whenever you have a power of negative number, it means your value is very, very small. Now, greater than 4, can we find the probability of greater than 4 directly? No. We have to use the complement rule. Greater than 4 is same as 1 minus probability of x less than or equal to 4. Equal to 4. And so we can use 1 minus p binom. We start with 4, then size equal to 40, and what we have, probability of success equal to 0.35. So this is if in case you have to deal with greater than. Okay, now let's move to a question where you have to deal with a Poisson distribution. So if your x is Poisson with lambda 7.4 and you want to find the probability of exactly 6 equal to 6 only, means you use d pos. Write your value of x, then write your lambda. Run the code. So we're getting this. You can run your answer into the number of decimal places required. Okay, x less than or equal to 6. Now we don't have only equal, we have less than equal. In that case, we cannot use d, we use p poise. Then write your value of, you start with the 6, then lambda equal to 7.4. Next, less than 6. Is 6 included? No. Less than 6 means it is less than and equal to 5. So when we write the code p poise, we cannot write d poise because we have less than and equal sign. So we write p poise. We start with 5 and then lambda equal to 7.4. Now for greater than, as I mentioned before, we don't have any code for greater than. We have to use 1 minus p. X is less than or equal to 6. Use complement rule. So 1 minus p poise. P poise is the code for less than and equal. In case of Poisson, write your x as a 6, comma lambda equal to 7.4. Okay, this is regarding discrete probability distribution. Discrete probability distribution are Poisson and normal. So the code D is only used for discrete probability distribution. In normal probability distribution, we have only one code. We have the code P. P norm is only used. We cannot use D norm in normal distribution. Normal has a mean 60 here and standard deviation of 9. We want the probability of less than 55. Even if you don't have the equal sign, but still the code is same, because normal distribution, if you have less than 55, it is same as if you have less than or equal to 55. Because normal distribution is a continuous distribution, and whenever you find the probability of normal in the theory, you're finding the area. So whether that point is there or not, still you are going to integrate from that point. So less than and less than and equal probability are exactly same. So we'll use p norm. X is 55, comma, the mean is equal to, here is given as 60, and standard deviation is given here as 9. Run the code, and this is your answer. You can round your answer. Now again, this p norm code is used for left, for less than. So to get the probability for more than or for the right side, we use 1 minus p norm. And we use 1 minus probability of x less than 55, which is same as 1 minus p norm. Write your x, 55, mean is 60, and standard deviation of 9. This is your answer for probability of x is more than 55. What if you have between? We will take first of all p norm of the largest number we have, 70, mean is equal to 55, SD is equal to 9. and then we'll take minus p norm of 55, 55 minus mean equal to 60. Okay, here I made a mistake. Here it should be mean is 60 and standard deviation of 9. So this is your final answer for between probability. Okay, whether you have equal or you don't have it normal, it doesn't matter. Okay, that is for finding the probability in general or finding the probability using probability distribution. Hope it's clear to you.